So who can explain just the general shape that you got for your function? Sean?
V.
It's that V, right? And here's the reason why. It's the distance away from 0. Distance is always positive. So I'm not going to plot them all, but there's like a 5, 5 up there. There's a negative 5, 5 up there. I see a 4. That'd be 4, 4. I see a 0. I see a 3. 3, 3 maybe. Where's another negative? Negative 1, 1. Okay. And why am I not connecting these? This isn't all of them, but why am I not connecting these? Because there is like a V-shaped thing happening.
Because the numbers aren't in between.
Yeah, the numbers aren't in between because I have daily values, right? So I could have a number in between somewhere, but unless that daily recorded data shows me that number in between, it's not on the graph. So if I make it continuous, that's saying all of them. Well, all of them are options away from 0. Each day has a specific temperature. So I'm going to let this stay discrete, okay? All right, we good with that? So the way I would write the rule for this, there's 2 ways. My personal favorite way is something like y equals the absolute value of x, or f of x equals the absolute value of x. That's my personal favorite. Another way you will see this, though, is like the domain range kind of function rule, where you have the brackets or something, and you'll say input x. When will input x have the same output as the input? What kind of numbers would have the same output as input?
Or the actual guess.
So, like, look at numbers we put in.
0.
0 would, what else?
4.
4 would.
3.
3. So all 4, 3, those are all what type of numbers?
Whole numbers.
They are. But what about 1.5?
No.
Yeah. So 1.5 pumps out 1.5. So one thing you could say is, for those positive inputs, they always, so anything that's bigger than or equal to 0, they always pump out whatever you put in, right? Now, if we're talking about the numbers less than 0 then, what has to happen to those numbers to get the correct output in this situation? So if I put in a negative 4, it doesn't pump out a negative 4.
It would be the absolute value.
It'd be the absolute value of negative 4, which the absolute value of negatives always become positive. So I can write that like this, negative x, because that means the opposite of. So what this rule right here is saying is, for all the numbers 0 or bigger, whatever you put in, it pumps out. Right? 5 goes in, 5 comes out. 1.5 goes in, 1.5 goes out. For the other one, anything less than 0, for example, let's say negative 2. When negative 2 goes in, when it comes out, it is the opposite of negative 2, which is 2. So if we're going to write it like those rules we wrote for the piecewise functions, it'd have to kind of look like that with those inequalities. We good? Now, I have a personal favorite. Let's do a vote. Let's see what's yours. Who likes the top function, y equals absolute value of x? That's my personal favorite. Who likes the inequality way more? Okay. Here's what's interesting. First hour was like 50-50. Second hour was like almost all absolute value. And then this hour is a mix. 50-50 again. Yeah, cool. So what we're going to do here is we established this graph already with the temperatures, right? F of x equals absolute value of x. 0, and it's how far away it is from 0. So I want you to take like 1 minute with your partner or your group, your table group, and tell me, what do the rest of these have in common and what is different? What do they have in common and what is different? That's all I want you to do next. So let's talk about first, what are you noticing that these all have in common? What's something they all have in common? Brandon?
They all have absolute value.
So absolute value, absolute value, absolute value, absolute value. Got it. What else is in common, Maddie?
They're all in V shapes.
All the graphs are shaped as a V still. Okay. What else is in common, Zeph?
They're all on one of the axis lines.
Ooh, somewhere. You're saying, yeah. And
Like they're
I'm bringing
all-
your attention to everything but that one, okay? So I'm asking, what's in common with all of these 4? What else is something in common, Ryan?
They all got 2s.
There's 2s up in there. Ooh. Okay, so I think we got all the in common. What's different? Sean, what's something that's different between some?
They all have different absolute values.
So each place inside the absolute value, something's different, except right here. Absolute value of x, absolute value of x. So what's different about those two, Sean? 'Cause the graphs are different, but what in the function's different?
Oh, they start from a different place, so negative 2.
Oh, a -2 versus a +2, okay? Cam, what are you noticing that's different?
There are 2 that are positive and 2 like with the.
2 that are negative, yeah. So what I want you to attempt to do here is make somewhere between 2 and 4 rules about what these functions, what the 2 is doing to these functions to make the new graphs. This is like our baseline graph. Use this as your base to explain what's happening with these 2's. How is it changing the function? You're going to use words. Use words to come up with the rules. When we tighten it all up, get it all together, we're going to make 2 kind of general rules with sub rules. But you could use up to 4 rules if you need to. All right. So get after it. Let's try to get these. Let's try to get these rules down here. I'm going to make us some space. You guys are going to help me make this rule. The first general rule I want to make is if the 2 is inside the absolute value. Okay? So inside the absolute value means we're looking up here. So who can tell me how that 2 is changing my function, my graph function there? Sophia?
Inside the absolute value, it means it's on the x-axis.
So it's touching the x-axis, right? Yeah. And it's changing where it touches. So the -2, so when it was negative, well, let's go positive first. When it was positive, how did it shift it? It shifted at how many?
2.
Yeah. So when it was plus, it shifted us left. Do you guys see that? And when it was minus, how did it shift us?
Right.
Right. And that seems a bit counterintuitive, correct?
Yeah.
So here's the reason it works. This spot right here where it hits the x-intercept, what does y equal? Or what is the output?
0.
The x is -2 there, or +2. What is the output, the y value? 0. So to get this to be 0, what would this x have to be? No, it had to be +2. Because 2 minus 2 is 0. So that's where there's that +2, 0 right there. Okay? Over here, to get that to equal 0, what would x have to be? -2. So these are like this function we saw yesterday. Remember that yesterday?
Oh, yeah.
And our graph started at 47, 0 to the right, even though it's -47. The reason is that's the 0. That's our place of focus, right? So it does seem counterintuitive. Usually, positive goes right, negative goes left. But for the absolute value function, it has to shift where our 0 is, so that -2 to account goes 2 right. The +2 to account has to go 2 left. Okay, so that takes care of our inside. Everybody have that down? Because you're going to want that probably. Everybody's got that down?
Yes.
Okay. So next up, let's talk about when the x is outside. When the x is outside of the absolute value. I'm going to change colors here quickly. So, or when 2 says, cash me outside.
What?
Okay? That's the math terms. So when 2 is outside, what happens when it's positive? Who can explain what happens when the 2 is outside and positive? What happens to my graph? Ivy?
Well, it shifts on like the y-axis.
Which direction, up or down?
Positive shifts up,
Up on y-axis, I like that.
and then the negative shifts down.
Yeah. And let's talk about y. Well, once I have my x value established, so I like to think about input. So in here I'm going to put in 4. What's the absolute value of 4? 4. And then that -2 is going to do what to my output, though? Output being y, subtracted 2. So it's shifting everything down at that point because it's changing my output. Okay? Looking at this one here, let's say I put in a -5. What's the absolute value of -5? 5. So +2 shifts my output up to 5, 7, right? Yeah. So it's shifting up and down here. So big idea is inside the absolute value, shifting me left and right. Outside the absolute value, shifting me up and down. Right? Kind of cool little, and it's going to work for all numbers you put in there. Okay? Now, here's where we're going to see if you've got this. You ready? you're going to match these equations with their functions using those general ideas. All right? I'm going to give you 2 to 3 minutes here, I think. So I'm not even going to write anything. Looking at equation 1, who can tell me what this is saying to do to the graph from 0? Who can tell me what this means to do from 0? Sean?
Move it 3 to the right.
3 to the right. So here we go. 3 right. Everybody good? Okay, second equation. This one's a little tougher. It tells me to move 2 ways. Lily, you got it? What does this tell me to do? Which direction?
That one tells you to go over to the right 9 and up 3.
Right 9, up 3, which puts me here. Yeah, mine doesn't have letters, so I'm just going to point to it. Right 9, up 3. Okay, Ryan, what does this one tell me to do? Equation 3.
That one tells you to move 6 down, so that would be
6 down, right? Here we go. Zeph, what does this one say to do?
For that is move 3 to the left.
I don't see that, do you?
Yes.
It's the daily double or something like that. So it's going to be this last one where we're going to draw our own. 3 left. Thank you, Zeph. And Maddie, this one. What is this one saying to do? What moves?
It's telling you to move move 3 to the left and down 6.
3 left, down 6, which puts me here. Do you see how that matching's kind of nice once we understand the rules? It's kind of fun, a little puzzle. I like it. Awesome.